Find the derivative of y equals the square root of 4t squared plus 9 divided by 6t minus 5 to the 2/3 power. So y here is the quotient of two functions. We have the square root of 4t squared plus 9 divided by 6t minus 5 raised to the 2/3 power. We're therefore going to make use of the quotient rule for the derivative, but before we do that, let's rewrite this numerator to a fractional exponent. 4t squared plus 9, it's to the first power second root, so 1/2 power all over that denominator. 6t minus 5 to the 2/3 power. So quotient rule for the derivative y prime, or dy dt. The derivative of the numerator, it's a power rule. We'll bring down the power, 1/2. Leave the inside alone, 4t squared plus 9. Subtract 1 from the power, I will call it 2/2. Multiply by the derivative of the inside to complete the chain rule. That'll be an 8t. Derivative of the numerator times the denominator left alone, so 6t minus 5 to the 2/3, minus the numerator left alone, 4t squared plus 9 to the 1/2, times the derivative of the denominator. That's a power rule. We'll bring down the power, 2/3. We'll leave the inside alone. We'll subtract 1 from the power. I will call it a minus 3/3. And then multiply by the derivative of the inside, which is a 6, to complete the chain rule. All of this divided by the denominator, 6t minus 5 to the 2/3, denominator squared. So y prime, or dy dt, will be in the numerator. I'm going to put the constants together. I have an 8 and a 1/2. Well, 8 times 1/2 is a 4. So I have a 4. I have a t right here, so I'm going to move that t to the front. Everything's multiplying each other. I have a 4t squared plus 9 to the 1 minus 2, which is negative 1/2. I have a 6t minus 5 that'll be raised to the 2/3. Then I have minus, and in the second term I'm going to put the constants together. Well, I have a 2/3 and a 6. Everything's multiplying each other here. And 2/3 times 6 will be 12/3, or a 4. So that'll be a 4. And then I have the 4t squared plus 9 to the 1/2. And I have the 6t minus 5 to the 2 minus 3, negative 1/3. And all of this is over 6t minus 5 to the 2/3 squared. Now, raised to an exponent raised again, you multiply the exponents. 2/3 times 2, you multiply the numerators, 4/3. Now our next step, we have negative exponents in the numerator in both terms. One option is to move this to the denominator of this first term and move this to the denominator of the second term, respectively, and then we'll have each of them over those to the positive exponent. That's one option, but then we'd have to get the common denominator of that, which would be kind of messy. Another option is to factor the powers, which will be a little bit easier in this circumstance since we have multiple negative powers. We might want to just attempt the factoring instead of the common denominator. Now, if we're going to do the factoring, it's all about factoring the numerator. Now, in the numerator, I have a common factor of a 4. I will start with that. So I have a 4. Just factor that out. I'll be left with a t, a 4t squared plus 9 to the negative 1/2, a 6t minus 5 to the 2/3, and then minus a 4t squared plus 9 to the positive 1/2. Remember, I factor out the 4, so it'll just be a minus 1 in front of that. And then a 6t minus 5 to the negative 1/3. All of that is over that denominator, which I'm just going to leave alone. 6t minus 5 to the 4/3 power. So our derivative can now be further factored. We already have a 4 that's factored out, but if we look, we have powers of 4t squared plus 9 that can factor out from both terms. Here's one of them, it's negative 1/2 power, and here's one of them, it's positive 1/2. You can factor out the lower power. The lower is the negative 1/2. That's lower than a positive 1/2. So we can factor out the 4t squared plus 9 to the negative 1/2 power. Now when you factor out, you're actually subtracting that exponent. You're dividing. You're subtracting that exponent. Well, it's a negative exponent, so we're subtracting a negative. So what we're doing is taking each of the 4t squared plus 9s, and we're subtracting a negative 1/2 from each of them. So I'm showing it up here. Subtracting a negative 1/2 is equivalent to adding a 1/2, and that'll become to the 0. And anything raised to 0 is a 1, so that will be completely removed. So all of this is going to get completely removed. Now this other one we're going to be subtracting a negative 1/2 from, and subtracting a negative 1/2, which is equivalent to adding a 1/2. 1/2 plus 1/2 is 1, and all of that will go to the 1. Remember, we're always dividing when we factor out, and we're subtracting the exponent. If it's a negative that you're factoring, you're subtracting a negative, which means you're actually adding it. So that will leave us for the first term, we will have a t. All this is going to be removed here, and that's going to become a 1, is what I showed overall. So there's what we should have left. So we have a t times a 6t minus 5 to the 2/3. And we should have a minus 4t squared plus 9, which will now be to the 1 power because I subtracted a negative 1/2 or added 1/2 to it. And then I have a 6t minus 5, and that'll be still the negative 1/3. We haven't changed that just yet. And all of this is over the 6t minus 5 to the 4/3 power. Now in our next step, we're going to factor out a power of 6t minus 5. So we have the 4. We have the 4t squared plus 9 to the negative 1/2. And now I'm going to factor out a 6t minus 5 to a power. Well, let's look what we have inside there. We have a 2/3 power, and we have a negative 1/3. We can factor out the lower, which is the negative 1/3. Now when you factor out a negative 1/3, you're dividing, which means you're subtracting a negative 1/3, which means you're adding 1/3. Now with this first one, if you subtract a negative 1/3 or add a 1/3 to it right there, you'll have 2/3 plus 1/3. And that'll go to 3/3 or a power of 1. And this other one, you're completely removing it and subtracting a negative 1/3 from a negative 1/3. Adding 1/3 to it to 0, and that whole thing will be removed. So that'll get removed, and that'll become a 1. There's what we should have left over. So it looks like we have a t times a 6t minus 5, and then minus a 4t squared plus 9. All of this is over a 6t minus 5 to the 4/3. So y prime, or dy dt, will be, the next thing we can do is these two negative exponents that are in the numerator that are multiplying everything, well, since they're negative, they can move now to the denominator and be called a positive exponent. That 4 will stay in the numerator. And inside the square brackets, I'm going to distribute this t into here. So that'll be a 6t squared minus 5t. And I'm going to distribute the negative into here, so that'll be a negative 4t squared minus 9. And all this will be over. Now remember, we moved those negative exponents to the denominator, so we will have a 4t squared plus 9 to the positive 1/2, and we will have a 6t minus 5 to the positive 1/3, and then we already had a 6t minus 5 to the positive 4/3 down there. Okay, in the numerator, let's combine like terms together. 6t squared minus 4t squared is a 2t squared. We have a minus 5t. That's not going to combine with anything. And then we have a minus 9, which also won't combine with anything. And then in the denominator, we are going to be able to combine these because they have matching base. We can add their exponents together. So we will have 4t squared plus 9 to the 1/2, and that'll be multiplying a 6t minus 5, which will now be to the 1 plus 4, or 5/3. So there's the derivative y prime or dy dt. We have one other thing that we can do with this. Since in the denominator we have that 4t squared plus 9 to a 1/2, we can rewrite that as square root first power, or just square root. So there's an alternative way to write this result. Quite often, if it's going to be a square root, it will have to be rewritten with the radical symbol. Other than that, though, nothing will change. So we have 4 times 2t squared minus 5t minus 9. All of that divided by the square root of 4t squared plus 9, and then multiplied with 6t minus 5 quantity to the 5/3 power. Either of those results are optional ways to write this derivative, y prime or dy dt.